Hello, AP Physics. This is my thinking on review number 7. And it says we have a student of mass M standing on a platform scale in an elevator in a tall building. The positive direction for all vector quantities is up. It says draw a free body diagram showing and labeling all the forces acting on the student, who is represented by the dot. Well, they don't say what the elevator is doing, so I'm going to assume that it's at rest. So that means that the forces on the student would be the weight of the student, or mg, and then the normal force, or the support force from the floor of the elevator, which I'm going to call the normal. And I'm going to have these equal in magnitude, or as close as I can get them to equal, showing that there is he's either at rest or moving at a constant speed. Next, it says derive an expression for the reading on the scale in terms of the acceleration a of the elevator and the mass m of the student. Okay, so if the elevator is now accelerating, then there would be a net force, and that net force would equal the mass times the acceleration of the student. And that net force would also equal... Okay, so I'm going to assume that the elevator is accelerating upward. So I would say that the normal force would be larger than the weight of the student. So I would say the net force would also be the normal force minus mg. So again, what are we doing here? We're deriving an expression for the reading on the scale in terms of the acceleration a of the elevator. Okay, so the scale is measuring mass, I'm going to assume, for the student. So I am going to, I'm going to say that the scale reads the normal force. So what I'm going to do is I'm going to set these equal to each other, and I'm just going to solve for the normal force. So the normal force would be the force upward coming from the scale. So that would mean that the normal force, or the reading on the scale, would be plus mg. So I'm adding mg to each side. So the normal force on the scale would be the weight of the student plus the net force, which would make sense. So I'm going to clean this up a little bit. I'm going to factor out m, and I'm going to have m is a plus g. So that would be the reading on the scale if the acceleration was up. If the acceleration was down, then this expression would be different. The net force would be the weight of the student minus the normal force, because the normal force would be less than that of the weight of the student. So then that would give me ma equals mg minus n, where now I would have n equaling mg minus ma. So I would have my normal force, or the reading on the scale, being m g minus a. So this would be the reading on the scale if it were accelerating down, and this would be the reading on the scale if it were accelerating up. And I don't think it says what it was doing, so I just solved it for both. Next question. Okay, next question, they give us this graph here, and it's an acceleration of the elevator against time. So it says an inspector provides the student with the following graph showing the acceleration a of the elevator as a function of time. During what time intervals is the force exerted by the platform scale on the student a maximum value? Okay, so where on this graph do we have the normal being the largest that it could be? Well, for n to be large, we would want the acceleration to be up. So we would want the net force to be up, or the acceleration to be positive. So I would be looking for a large positive acceleration. So the largest acceleration would be right here, I believe, at 1.2. So it would be during the segments of 12 seconds and 16 seconds. So my answer to C here, during what time intervals is the force exerted by the platform on the student of maximum value? I would say between 12 and 14 seconds. Or actually, sorry, 16. Between 12 and 16 seconds. Between 12 and 16 seconds, our normal force is at a maximum. And then the next part of C says calculate the magnitude of that maximum force. So, okay, so I could just use my expression here. And we could say that the normal is equal to the mass of the student, which they're saying is 45 kilograms, times A, which is from this graph 1.2 meters per second squared, plus G, which is, I'm going to say 9.8 meters per second squared. So this would just be 45 kilograms times, 11 meters per second squared. So 45 times 11 gives me 495 newtons. So that would make sense. I mean, if the student were at rest, the scale would read 450 newtons, roughly. So if it's accelerating up, that normal force should be larger than 450, and it is. Okay. And then the last question, during what time intervals is the speed of the elevator constant? Well, on this graph, a constant speed would mean that the acceleration is 0. So that would have to be this section here between 7 seconds and 10 seconds. So the time interval when the speed is constant is between 7 and 10 seconds. And that's D. So 7 to 10 seconds. And that's it for Physics Review AP Test number 7. All right, hopefully that went well. Have a good one.